Hey YouTube, I'm not quite sure how much of this I'm going to record because it's going to be a pretty sensitive operation, but I can at least take some video in between bits. So I have my nice 20 gigahertz signal generator here, and it has a problem with the programmable step attenuator. Specifically, the 20 decibel pad is not engaging. Given the behavior, and that I have complete signal quality, um, like while it's not engaging, that tells me that the pads that either contact the pass-through or contact the attenuator for the 20 dB, they're always down on the pass-through, even when it's being told to click up. So that's going to be straightforwardly an issue with the solenoid not doing its job, or the solenoid going up but maybe having come detached from the little plastic push rods that move it. Third option is the voltage to the pin that activates that attenuator is not getting sent. That's a maybe, but not terribly likely. And there's the option that there's a broken or failed wiring contact inside the attenuator to power the push-up segment of the 20 dB solenoid. Those are what makes sense to me. So starting off here, this right here is the step attenuator. It is 110 dB, so it has a 10 dB, 20 dB, and two 40 dB pads to give you all the options for those that 110 range in 10 dB steps. So I'm going to be pulling it. I have ESD precautions ready, but something else I thought of which just made sense to me is took a permanent marker and I put little witness marks to line up exactly how far of a turn everything was on. It's not quite the same as having the torque spec, which I wish I had. I can't find. It's annoyingly hard to find the data sheet for like the exact model of this. Most of the ones I find are a different model, or they're 24 volts instead of 15 volts, but whatever. So in lieu of that, I can at least put witness marks to show exactly where the turning stopped, and I'll just reinstall it right at that point. So that's it for this section. I might add more later, but most of the actual ESD sensitive and delicate work, like moving the rigid cables, I'm going to do off camera so I can be just concentrating on that. Right. Okay, so here we have the attenuator partially disassembled. We have it disassembled down to the relatively safe level. So I'm grounded by my leg right now. What we have here is a version that uses one of the circuit boards. And if you look, where is it? Right there. It looks like it has had rework done on it. Looks like that's a tantalum cap that's maybe been replaced. But I mean, there's flux around here, so I'm also wondering if someone tried swapping a control board. And there's a little bit of flux around these pins. But anyway, the easiest way I can think of to test this is, well, I need a driver for the attenuator to switch it around. I have one right here. It's not connected to the input, so there's going to be some maybe reflection going on, but yeah, this will allow me to drive the attenuator and literally watch the individual plungers. See, this part, this is the super sensitive part. This has the etched resistors on glass or quartz or some kind of crystal substrate or ceramic, and the like vapor deposition gold pads or whatever in there, very sensitive. Out here, control board, and for 15-volt solenoids, not as sensitive. So I'm going to set this up so I can watch it, and I'm going to see if I can just make these actuate and watch for which one doesn't actuate. Now, if I took this off, I could identify which of the four was the 10, the 20, and the 40s, because the 40s will be furthest apart to give the etched substrate the longest path for the most resistance, the most attenuation. The shortest one would be the 10 dB, and the middle one would be the 20. But if I can get away with not opening this, because again, it looks like a straightforward failure to actuate, not a problem with pads. We'll only go there if we need to. I'm going to try to service this and watch what's happening without opening the sensitive RF section. Okay, I have it set up and ready. We're going to power on the unit. You're not going to be able to see the front screen, but I'll read off what decibel level I'm at. Okay, I'm starting at negative 114 dB, lowest it should go. It should result in no change because it should start off on maximum attenuation. Oh, hello. Interesting. That pad engaged. Just from power on. I'm gonna guess that that's the 20. Because the issue was with the 20 dB section not engaging, and up would be pass-through, whereas down would be activating. Wait. Let me think this through. Pushing down would be activating 20 decibels, so lowering the power output. Now I have to ask myself if I'm incorrectly remembering what's going on. Let's try this again. Okay. There. That's the 20. This engaged, that engaged, that engaged. Down is engaging the attenuation. So this is the one that didn't engage. Now, let's check for voltage. Actually, no, it's really temporary voltage. We'll need to capture it with a scope, probably. Okay, changing the power level while the RF is turned off doesn't change this. It makes sense, it doesn't need to. So I'm going to go ahead and turn the RF on, and I'll run it through the whole power level. We're at 114, I'm going to scroll. $101 dB, 100 dB, 91 dB, 90 dB, 81 decibels, 80 decibels, 71 decibels, 70 decibels, 61 decibels, 60 decibels, 51 decibels, 50 decibels, 41 decibels, 40 decibels, 31 decibels, 30 decibels, 21 decibels, 20 decibels, 11 decibels, or negative 11, sorry, negative 10, negative 1 dB, 0 dB. And I think after this, it's all about increasing the power output from the oscillator, or from the generator, because you're no longer removing any signal power, you're adding. So I just turned the RF off. So yeah, it's that one right there that's not engaging. Alright, I'm going to do some examination under a microscope. Okay, so I did a resistance check on the coil for this, and it's not shorted and it's not open. I get normal expected resistance values. It says 15 volts. I've gradually turned up my power supply. I'm currently at 9 volts. Pushing a solenoid this way takes less voltage than this way. So this is the 20 dB. This is the one that's having problems. Now, that pin right there that I'm hovering over, this one, that is common positive. and this runs on 15 volts. So I'm basically doing the least amount of voltage I can to activate things. Like I said, I'm currently at 9. I was able to get the downward motion at 7.5. So this is negative from the power supply at 9 volts. That one doesn't quite do it at 9. I'm going to go up to 10. Ten works. Now that depresses. Okay, now it's pulling up a 10. So it took a little bit more voltage than the rest. So the solenoid is responding when it gets power. This one is. Now, I've blown it out with this because there was like a little bit of dirt and debris, and I could see schmutz on the plungers. So it's cleaned out a little bit, and I've manually actuated it as well. Next step is to plug it back in there and see if, well, I'm curious if we can drive it now, like if it was just stuck, or if it's a matter of something on the board not giving proper voltage on that. Okay, so this is the test setup. We have the SIGGEN plugged in. Yeah, there we go. We have the signal generator plugged in to the programmable attenuator. Not input or output, but the driver. Our scope, actually, let's reverse this. Okay. Our scope ground is connected to the plus 15 volt common rail for the solenoids. Our scope input is on the negative end of the portion that wouldn't activate. So we're going to try to drive this, and we're going to see, because it doesn't apply constant voltage, it applies a pulse. So we're going to see if we can pick up a 15 volt pulse on the scope. Sorry for all the wiggling around. Okay, something went wrong. I might need to run this off battery and not have it grounded to float it. Let's try turning it on now that this is not connected to the scope. Yeah. Yeah, that was the problem. It was an earth ground issue. Alright, hopefully I didn't screw anything up. Let's stop here. Okay, I've unplugged HDMI and USB from my scope. I'm running it off battery. I've unplugged ground. It is fully floating. Just borrowed the battery pack that I use for my field soldering kit. So, alright, we have it connected in the same way. We have it set to extremely slow mode. Up here is 30 volts. We just saw a negative 15 volt pulse. Briefly. All of the solenoids are in the up position currently. Alright, I'm starting at 0 dB and I'm going to increase attenuation. So, that one clicked on. The problematic one just worked. And there's our pulses. It may have been mechanical. It may have been straight up just there was crap in there that was sticking it in place. Gonna pause here. Okay, I got interrupted before. We're gonna duplicate our results. Scope is still battery powered and disconnected from everything else except for what it's probing, so it shouldn't encounter any issues with ground. I'm going to turn this back on and run through the full power range to make sure everything clicks over. Okay. This plunger... Okay, so we may have not fully fixed it. This plunger is down. All the others are up. Oh, it turned on to previous state. And it turned on in the RF on state. Okay, so 0 dBm. One through 10. Uh, 11 through 20. Huh. Maybe this isn't the 20? I don't know. We'll take a look at it later. We're at negative 21 right now. Negative 30. Well, sorry, negative 31. Negative 41. -51, -61, -71, -81, -91, -101. All engaged. Sweet. Let's disconnect the scope just to eliminate the possibility that these being connected is doing anything. Yeah, we're all good. It was an issue of literally just, well, most likely, crap getting in either the plastic plungers, or yeah, those were what was dirty. Yeah, that was it. As is often the case, cleaning is the repair. Sweet. Relatively modern 20 gigahertz SIG-Gen, ready to be added to the bench. All in one day without even having to order parts. Which means I no longer have that as an impediment to rebuild the top instrumentation shelf because I have so many equipment updates to integrate.